Okay, so if we were to continue along that frame of mind, for the first trial, we had one no-show, so that means 23 people arrived. For the second trial, we had one no-show, still, once again, 23 arrived. On the third trial, we had 4 no-shows, and only 20 arrived. Okay, so for the fourth trial, we had 3 no-shows, and that means we have 21 people actually arrived. For the fifth trial, we had 1 no-show, 23 arrived. And on the last trial, we had no no-shows, so 24 arrived. So we want to see the average number of arrivals. So what we're going to do is actually add all these up and average it. So we have 23 plus 23 plus 20 plus 21 plus 23 plus 24, and divide that by 6. So our average in this case is 22.3. In other words, if we were to go back to our notes, on this, it says, estimate how many passengers will show up. Well, on average, based on this, we have 22.3, or around 23 customers actually show up, passengers show up. So this is how you do this using a random generator to predict the number of passengers show up. Let's look at example 1b. Suppose that in the past, 95% of the people who reserved a seat on a particular flight actually showed up. If the plane holds 118 passengers, describe how you would use a simulation to estimate how many passengers will show up. Well, in this case, 5% don't show up, right? So if I were to say 5 out of 100, that's about 1 over 20. So I'm going to need a 20-digit random generator here to simulate this because of that. So rand int, I'm going to go from 0 to 19. That'll give us 20 digits. And we have 118 passengers, so we need to make a string of 118 of these. So we're going to do it the same way that we did with 1 to 10, 1 to 9 on this one, with 24. And we would take like maybe 6 simulations in all, and find out how many zeros show up, and find the average. So again, after putting it on my random generator on my calculator, I have 6 trials on the number of no-shows, and that's when it only shows up as a 0. You can have a number of 10, but that's not what I'm talking about. I mean a pure 0. So the number of no-shows on the first trial was 7, and the number of no-shows on the second was 7 again, 9, 6, 6, and 2. So my total passengers that showed on this one was 111, 111 for this one, 109 for this one, 112. This is 118 minus these numbers, by the way. 112, and then 116. So what I now need to do is to predict how many passengers will show up in a plane of 118 people. I'm going to add all these up and divide by 6 to find my average. So my average on this is about 112. So on example 1b, we can say around 112 people will show up per flight. That's what we can plan for. This one says, assuming 90% probability that a given passenger shows up for a flight, estimate how many tickets should be sold in order to fill all 24 seats. So once again, we have 10 out of 100%, so I'm 1 out of 10. So we can use a random digit number, and I got that, by the way, from this. Random digit from 0 to 9, and put that into our calculator. And every time a 0 shows up, you would have to start over and count until you get to 24 consecutive non-zeros. So, for instance, the calculator comes out with a 2, a 6, a 5, a 0. So I have only 3 consecutive here. I got to start over again, but I'm going to keep track of how many I have to sell. So say it's a 6, a 7, an 8, and so on, until I get 24 of them consecutive. So finally, let's say I didn't get another 0 here. I would have a total of 28 tickets that I had to sell. Okay, so we would want to do this type of a trial, like maybe 10 trials. After we have 10 trials, we're going to take how many tickets each time it took to sell, 24 consecutive, and say like the second one it took us 25 tickets, maybe the next one we had 50. We would take all those, add them up, and find the average. On this last activity, we're looking at 2 brown-eyed parents that have a blue-eyed child if they each carry the recessive gene for blue eyes, assuming that in these cases the probability of blue eyes is 1/4 and the probability of brown eyes is 3/4. Design a simulation to estimate the probability of having exactly 1 in 3 with brown eyes. So what you're going to want to use is a random generator again, and I'm going to use the numbers 1 through 4, okay, where the number 1 is going to be a blue eye, and the rest of them will be brown eyes. Okay, so if I do that, and I do over, say, 40 trials of this with 3, pardon me, I should have put a 3 there because I have 3 children. We're looking at 3, exactly having 1 of 3. So if I do this 40 times, we can come up with a percentage. So on this, if I rand int 1 to 4 and 3, because I have 3 children, I'm going to get this one first. So we have no blue-eyed children in this one. Specifically, though, we are looking for a time where you only have 1 brown-eyed child. And in this case, we have 3 brown-eyed children. Let's try it again. Once again, we have 3 brown-eyed children. We have 1 blue-eyed child, and 2 brown-eyed children. And so we need to do this 40 times until we get one where we have only 1. And here we have 1 of them. So we can count that as 1 time out of 1, 2, 3, 4, 5 times so far. If we do this 40 times, you should come up with a relatively small number. So in 40 simulations of this type, I only had 4 groups of 3 that had only 1 brown-eyed kid. So 4 out of 40 happened. So the probability for that is 4 divided by 40, which is 0.1 or 10% of the time. Designing simulations, this is section 6, 7 of your book. And this is something that is actually very practical. You will actually see it being used in a lot of things that you read in the paper. So let's just talk about this. A simulation of a real situation is an experimental model that attempts to capture all aspects of the original situation that affects the outcomes. A simulation allows people to plan and predict. Okay? Examples of simulations for which it would be impractical or not feasible to wait for the real event to gather data. Here's a big one, crash tests. We want to know what are the possible outcomes of a crash test on a car before we actually start selling that car. So they're going to do some simulations to figure that out. So the reason why it would be impractical to wait is because you'd have deaths on your hands. So you want to do it beforehand, okay? The other one would be a pre-election poll. We see a lot of that coming up here. Pretty soon we'll be seeing more now that caucuses are over. Fire drills is another one. This is a practical one that we just practice just to simulate something so we know exactly what to do if it should happen. Okay? So those are real life simulations. In this lesson, we're going to simulate an experiment by assigning numbers to possible outcomes. So, for an example, let's read this situation. A manufacturer of sugar oat cereal is promoting sales by putting sports stars trading cards in each box. The cards are randomly distributed so that the chance of obtaining each one is equally likely. Children are encouraged to collect a set of all 4 cards. And Bobby wants his parents to buy the cereal, but they think they may need to buy many boxes in order to get all 4 cards. First, we assign numbers 1, 2, 3, 4 to the 4 outcomes from buying a single box. Okay, what I want you guys to do is give me 4 sports cards that you would like to see if you were in.
Like this, right?
Yep. So I'm thinking Mauer. Well, who else?
LeBron. No. Ovechkin. LeBron.
LeBron. I don't know how to spell it. I can't spell, you guys, so I'm already telling you right now I can't spell.
What's that say?
Babe Ruth.
What? LeBron. Kind of says LeBron.
Is it L-E?
Yeah.
Okay, sorry.
No.
Oh, no, not him. I refuse to put him down. Who else? Wagner? Okay, so these are 4, just say these are 4 that they're putting into their cereal, and this kid really wants to get them, okay? So, what we want to do is simulate the chances of getting all these cards. We're going to use a random number generator command on the calculator, okay? Now, if you don't have a calculator or a CAS, you can do this online. You can actually Google random number generator, and there's about 100 of them online on the Google, okay? All right. So, turn the page. First, we're going to perform one trial to figure out which card comes up first. We're going to do one trial to see which number comes up first. I'm going to use my CAS here. Okay? So, I'm going to tell the CAS by typing into it, maybe. It looks like it's frozen, doesn't it? Okay. Rand int. And I'm going to tell it to pick between numbers 1 and 4.
Wait, how do you do that rand int?
Just type it. That's just the way the function's written. Okay. So rand int 1 through 4. So if I hit enter at this point, it's going to tell me that it drew a 3. So which one was number 3 on our page?
Babe Ruth.
Babe Ruth. So they got a Babe Ruth, that first one. Okay? So on that first part right here, you're going to write a 3 for trial 1. Okay?
No, when you write Babe Ruth.
You can just write a 3 because we know that 3 stands for Babe Ruth. Okay, so then we're going to do it again. Just hit it again. 1. So they drew a what this time? Mauer, okay? Yes, there's a card in every box.
So success, do we say yes?
No, they won't get success until we get all 4 cards. Okay? So let's keep doing this until we get a success.
Would you like me to just do it?
So what I'm going to have you guys do in just a minute is I'm going to have you guys do at least 10 of these and find your own data. Okay? So here we got a 3. We got a 3 this time.
Alright, got it.
Okay, so now I'm just going to keep going. I want somebody else to write this down for me, okay?
Got it.
All right, good. Okay, so we got a 4. Write it down for me. Got a 1. We got a 2. So finally, do we have all 4 of them represented? 1, 2, 3, 4. Okay, so how many times did it take us to get all 4 of them represented? 6. Okay?
Mine took 7.
All right. So what I want to do is go through and do this again and find out how many times it takes us to get all 4 represented. I didn't. I was looking past you.
Sorry.
Using repeated trials to produce relative frequencies to establish probabilities is often called the Monte Carlo method. Okay? So there are 3 steps to this method. First of all, you need to determine how the situation will be modeled.
Are you recording? Are you recording? Are you recording? Why did you shut the door?
Okay, number 2, we're going to define what Okay, so step 2, you're going to define what constitutes a trial. And what will be recorded. Okay, so on the last thing that we were doing, remember we had a random number generator pick out a number from 1 to 4. And that told us which card was drawn, right? Okay? So we recorded the number that was drawn. Step 3, specify the number of trials that you're going to have to do. And how the estimated answer will be obtained. Okay, so for an example, we have 24 tickets are sold for the small plane, and the probability of arrival for each passenger is 90%. So we want to use a simulation that will estimate how many of the 24 passengers will show up. So basically it's saying 1 out of every 10 passengers, right, are not going to show up for the flight. Okay? So we can use a random number generator. We can use the rand_int on the calculator, going from 0 to 9, okay? And we can put in, we want it to figure it out 24 times, because there's 24 passengers, right? 0 to 10 is 10 digits, right? Okay, so that's why I'm doing 10 digits, because 1 out of 10 are not going to be there. So what I'm going to do is do this on my calculator and look at the string of 24 that comes out. And I'm going to see which passengers don't show. And I'm going to say 0 is my no-show. Okay? So, here, let's do this. I'm going to type in rand_int. see that now. Okay, syntax error. Huh? I think I can. I don't know why it's got so many. Okay, so now I'm going to write randint, and I'm going to say 0 to 9.
You didn't make the I capital.
Yep, I know. And I'm going to say 24. Here we go. So notice passenger number 2. Did they show up? No. And if you take the string and keep going, how many passengers didn't show up? Looks like just 1, right? I see just 1. Okay? So we can do it again. And I could have just hit enter again, right? Okay, here we go. So which passenger didn't show up on this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Passenger number 11 didn't show up. And that was it. So 1 passenger didn't show up there. So what we want to do is do this 6 times. Just do 6 trials. We're just picking 6 right now.
Last time did you pick 10? Just pick 10.
Yep.
That was for you.